Looking at this first do now problem, the first thing that we need to do is change any subtractions to additions. So as we look at this, we're going to change this to add the opposite. That makes this a negative 2 to distribute in. 3h plus negative 2 times 1 is negative 2, plus negative 2 times 4h would be negative 8h. Go ahead and commute our like terms, so using the commutative property, negative 8h plus negative 2. This is negative 5h plus negative 2. As we come down and look at our answers, we can see that we can change this addition back to a subtraction, negative 5h minus 2. That gives me answer choice C. Sliding over here, write the expression below as the product of two factors. So we're going to factor this out, figure out what we're multiplying here. My common factor here is looking at the variables. There's no common factors amongst variables because this one doesn't have a variable at all. And our common factor amongst the coefficients is 2 times 3m, 2 times 4n, and 2 times 2 gives me 4, and that's answer choice A. Alright, let's look over at our AM for today. Today's AM Kipsters will be able to use identity and inverse properties in expressions. So we've talked a lot about identity and inverse property before. Today we're going to formalize a lot of that information that we've already learned. So looking at this first question, it says, in the morning, Harrison checked the temperature outside to find that it was negative 12 degrees. Later in the afternoon, the temperature rose 12 degrees. Write an expression to represent the temperature change. What was the afternoon temperature? All right, so quickly write down that expression. And this should be pretty obvious to us that this is negative 12 plus 12. And so that when we think about this, we know that that means that the afternoon temperature is going to be 0 degrees. All right, let's go ahead and rewrite each subtraction as adding the opposite. And then find the sum. So looking at each of these problems down here, go ahead and do this on your own. Rewrite each of these subtractions as adding the opposite, and then go ahead and give me the sum. Right. We're writing this as 2 plus negative 2. That's going to be equal to 0. This will be negative 4, negative 4. Change this to add the opposite. The opposite of negative 4 would be positive 4. Negative 4 plus 4 is equal to 0. The difference of 5 and 5, so that's 5 minus 5, which is rewrites as 5 plus negative 5, which is 0. G minus G, that's G plus the opposite of G, which would be 0. What pattern do we notice here? We should see that in every problem we use the adding the opposite, and then it adds up to 0. So looking at this for these first two exercises, we can see that these add up to 0. And this is what we call the additive inverse. Adding the opposite is the same thing as the additive inverse. So the additive inverse is equal to 0. Alright, go ahead and add all of these together in this step here. Change this one to add the opposite. Negative 4 plus 0. And D. So what do we recognize with all these? Well, these are all adding 0. So we recognize that the sum of a number and 0 is the number. And so this is the additive identity property of 0. As we come over here and we look at this, it says your younger sibling runs up to you, excitedly exclaims, I'm thinking of a number. He says, if I add the number 2 10 times, that's 2 plus my number, plus my number, plus my number, and so on. And then the answer is 2. What is my number? So we're looking at some number, 2 plus n plus n plus n plus, and so on. And he's saying, what is my number? And you almost immediately answer 0. The question is, are you sure? Is there any other number that you could use that could add repeatedly and still get 2? So you should be thinking to yourself, no, there is no other number. So, no, there is no other number that could be added without changing the value. So we can see this makes 0 a very, very special number, and then when we add it, there is no change. So a couple of things to think of about the exercises that we've just done. Just a reminder to us that when we add opposite, it adds up to 0. And then when we add 0, that doesn't change a number. And so this kind of puts together for us the really important concept of reminding us that when we have additive inverses, they lead us to the additive identity. Alright, it says write the sum and then write the equivalent expression by collecting like terms. So this is going to hopefully look at us for thinking about what we just talked about, how additive inverses can lead to additive identities and what that means for the expression. So this is looking for the sum of each of these, so it's 2x plus negative 2x plus 3. So combining like terms, 2x plus negative 2x, those are additive inverses. And then when we add 0 plus 3, that's 3. So additive inverse leads us to additive identity. Alright, so here we have the sum of 2x minus 7 and the opposite of 2x, so that's going to be 2x minus 7 plus the opposite of 2x, which would be negative 2x. Change this to add the opposite, so I can go ahead and use the commutative property and go ahead and commute my like terms. So commute. This is adding the opposites, so this is our additive inverse. And 0 plus 7, 7. Additive identity. Adding 0 doesn't change the value, doesn't change the identity of that number. The opposite of 5x minus 1 and 5x, so 5x minus 1, the opposite of that, so that's calling for the opposite of the group, 5x. And when we remember that how we do this, the opposite of a group is, so it's going to change this to add the opposite, is the opposite of all the values inside. So we change this to addition, negative 5x. The opposite of the negative 1 is a positive 1 plus 5x. Go ahead and commute our like terms. Negative 5x plus 5x plus 1. Additive inverses. Adding opposites adds up to 0. 0 plus 1 is 1. So again, we see that same concept that happens over and over and over again. It's going to be a pattern that we use a lot. We see commutative. Property. Adding opposites, so that's additive inverse, which we know is always going to lead us to the sum of 0. And since 0 is so special, we always end up with our additive identity. Adding 0 doesn't change the value. So at this point, you should feel like we're starting to sound a lot like a broken record here, and the takeaway should be, once again, when we use the additive inverse, we get 0, and because 0 is so special, when we add it, we end up with the additive identity all the time, over and over. Alright, let's look at the rest of our work now. Okay, looking at these 5 problems, you're going to do exactly what we did on the previous problems. With your partner, or in this particular case, since you're independent, by yourself, go ahead and write the sum of each of these, and then combine like terms, equivalent expressions, and then go ahead and I want you to be labeling the properties as well. So not a lot of space, so I have to write pretty small here. You can abbreviate your properties, but I want you to justify each step. So you're writing the expression, and then simplifying the expression, and justifying with the properties just as we did in the previous problems. So go ahead and do that, and then come back. Just a quick check on the first one if you needed to check in with this one before you move forward. You can see that we write the sum, and then the first thing that we need to do is we commute. Then we see the additive inverse because these two values add together to be 0. Then that leads us to this 0 plus 4b, which is the additive identity. Adding 0 does not change the value. Alright, go ahead and finish the rest on your own if you haven't already. Alright, as we look through, this is what our work should look like. Over and over again, once again, I think our main takeaway from this is that we continue to see this idea that we have an additive inverse leading to an additive identity. We have an additive inverse leading to an additive identity. We have an additive inverse leading to the additive identity. And so we can see that just constantly throughout this, we're getting, that helps us isolate these numbers that are not part of those inverses. And that's how we use this in equations all the time, is to isolate the value of something by using additive inverses to kind of make the rest of the things disappear. Alright, coming over here, go ahead and find the value of each of these expressions on your own, just real quick. So as we look through this, we should see that each of these gives us a form of 1. So we get the 12 over 12, 1. We have 4 over 4, 1. 9 over 9, 1. Here we have a negative times a negative, so that gives us a positive. That's why we get negative 3 over negative 3, positive 1. Negative times a negative, once again, that gives us negative 30 over negative 30, which is equal to 1. So here we can see these are what we call multiplicative inverses, because they multiply up to 1. So we see reciprocals being multiplied are the multiplicative inverse, because these are all reciprocals of each other. And when we multiply them, we get the form of 1. And so again, we've seen this before, the product of a number and its multiplicative inverse, or the product of a number and the reciprocal, is going to be 1. So let's look at this. It says the multiplicative inverse of 1/5 times this group. We're going to be looking at this. So the multiplicative inverse is 5 over 1. That's its reciprocal. Multiplicative inverse is its reciprocal. And 2x minus 1/5. So we're going to change this to add the opposite and distribute in. We get 10x plus 5 over 1 times negative 1 over 5. So we get, sorry, ran out of space here, 10x plus negative 1. So what we see here is we use distributive. And this multiplication is the multiplicative inverse. So we get this really ridiculous. Really, we get here a subtraction of 1. Multiplicative inverse of 2, so that's 1 over 2 is our multiplicative inverse, times 2x plus 4. So we distribute this in, gives me 1/2 times 2x plus 4 times 1/2. That gives me 1x plus 2. So in this process here, this is our distributive. And here we see this multiplication gives us 1 because this is the multiplicative inverse. And here it's asking us to multiply the multiplicative inverse of this, so that's the reciprocal. That would be 3x plus 5 over 1. Which is really just 3x plus 5 times 1/3. So again, this distribution gives me 1/3 times 3 over 1x times 5 times 1/3. This is multiplying reciprocals. That gives me 1x plus 5/3. So again, same thing. In this particular case, we're using distributive property and then the multiplicative inverse. So it wants us to write the product of each of these. I'll go ahead and do the first one, and then you'll finish the rest on your own. The reciprocal of 3, so the multiplicative inverse, and negative 6y. So we have 3, sorry, the reciprocal of 3, so 1/3 times negative 6y plus negative 3x. Distribute that in. 1/3 plus negative 6y plus, sorry, 1/3 times negative 6y plus 1/3 times negative 3/1x. That's going to give me negative 2y plus negative 3/3. So really just a subtraction of 3/3 times x, which is really negative 2y plus 1x. So again, as we're looking through this, we end up distributing, and this becomes our multiplicative inverse, which is 1. Go ahead and do the last two on your own. So once again, we see a lot of multiplicative inverses in here. Here we have a multiplicative inverse, and here we have a multiplicative inverse. These multiplications of 1, and that lead us to these multiplications of 1. So that's where we're kind of moving forward with our work for today. In the process of that, every time we use that multiplicative inverse, we know that we end up multiplying by 1, which really does not really change our identity. So again, we kind of see the same idea with our multiplicative inverses. Multiplicative inverse leads to the multiplicative identity. So inverses lead to identities, which helps us isolate values to get them alone. So again, we see that over here. Isolates the h, gets the h to be more isolated, more alone. Isolates the x, gets the x to be more alone. Same thing up here, over and over again. This is helping us get those values more and more alone. Okay? And that's the whole idea, and that's how we've used this 100 times when solving equations. Inverses lead to identities. And that's your key takeaway from today's lesson. Inverse properties lead to identity properties, which help us isolate things. We can get things more alone because we can get them to the point where we're really just adding 0 to them. Alright? Go ahead and flip on over to your alone time and complete the couple of alone time problems.